Hello and welcome to this taster session on A-level maths at St Thomas Aquinas. So first of all, welcome. We're going to now go through a few slides just to give you a little bit of an idea of the way that we do things in terms of maths at St Thomas Aquinas, and also give you a little bit of a taste of the course as well. So first things first, what skills do I need? So at St Thomas Aquinas Catholic School, our entry requirements are a strong grade 6. Now you do have to be good at maths to do A-level maths. I know that sounds like common sense. Now the reason for this is that it is a tricky subject. It's one of the trickiest subjects that you'll be asked to do at A-level if you want to do it. Now, you do have to have really strong algebra skills, really strong algebra skills, because that is the basis of everything that we're going to be doing. And you should also be capable of logical thoughts and being able to analyse a problem and find a solution with a step-by-step instruction. So you should be able to look at a question and basically figure out what you need to do. So these are some of the skills that were required. So, basic knowledge. So GCSE topics are fundamental to the understanding of mathematics. So these include, and I've already mentioned this, so basic algebra. So things like laws of indices, this is really important when we're doing a topic called differentiation. Expanding and simplifying and factorising. I mean, those are just basics when we look at A-level. So you've also got to have a strong understanding of what a quadratic function is. So whether that's factorising, using the formula, completing the square, drawing the graphs, you've got to be able to do all of those things. Equations and inequalities, particularly simultaneous equations. Now that's not just the normal linear simultaneous equations. What we're thinking about here is the quadratic simultaneous equations, and sometimes even cubic or logarithmic or trigonometric quadratic simultaneous equations. So there's a range of things going on here. And I mentioned at the end here, sine and cos rule, but all of A-level trigonometry, all A-grade trigonometry. Now trigonometry dominates some of the papers, so you've got to have a strong understanding of sine, cos, tan. And we actually move on to other things like sec, cosec, cot. So all new types of trigonometry, which you might not have seen before. So, over the summer holidays, every single subject will be giving you a document to help you to start the course. Now in maths, we've got a document here which is called Mind the Gap. And this is basically all of the key skills that you'll be required to do to take A-level maths. So it starts off quite easy with things like factorising, but then it gets onto the trickier stuff, which is like simultaneous equations or inequalities. Now remember, these are the basics required, and you've got to have a really strong understanding of everything that's in this pack to help yourself. So your teacher will collect this in September, and we'll be looking for evidence for the work that you've done over summer. And there's also actually more websites that you can have a look at. You can have a look at the CIMT website, and I'll post a link to the document in below this video, and I'll also post a link for the CIMT website below this video as well. But also you can find all of this on the school website. Okay. So in the first half term, so in the first 2 weeks, you'll have a diagnostics test, and this is going to be based on A-star grade GCSE level questions. So we're talking like 7, 8, 9 here, and a poor result in this, typically below 40% or 50%. Will lead to discussion about your suitability on the course. So we've got to make sure that we're doing what's right for you. So we want to make sure that this course is for you, because there are a lot of students who actually take maths and then don't work as hard as they should and actually end up coming out with a U or an E. And actually, if it's not the right thing for you, then there are other courses that you should be taking. So we do this in the first 2 weeks just to make sure that we know that you can actually do it. Now, 40 to 50% does sound like a low pass rate. However, these are just questions which are on, as I said, the 7, 8, 9, the really tricky questions which you'll get in GCSE, which has to be your starting point for A-level maths. I talk about the fact that you need a strong grade 6. Now, I say a strong grade 6 because realistically, a 7 topics which are 7 or plus are the ones that we're going to be looking at. And if you're already struggling with things which are at grade 6, then you might struggle with this course. Okay, So you'll be set 2 homework tasks a week, one by your main teacher and then one by your stats and mechanics teacher. And these could take about 2 to 3 hours to complete. This varies week on week. Some weeks you're going to have loads to do, some weeks you're not going to have loads to do. But there's also a brilliant setup that we've got for your supervised study period, so extra work that you should do with completing as well. And anybody who wants those top grades, so A star, the really top end A-level grades, will always do this extra work. It's not just a case of I do the homework and I get my grades. You have to push yourself in this. You have to push yourself to the real top end if you want to get it. So let's have a little look at the course content. So it's split up into 3 parts: pure mathematics, statistics, and mechanics. Now, you've seen some of the things in pure mathematics before. So some of the things you might have seen before are coordinate geometry. So this is equation of a straight line, equation of a circle, things like this. You've also seen a little bit of trigonometry, and we stretch and push and develop that. But there's a lot of new things on there. So proof is a new one that you might not have seen before, algebraic proof. In fact, you probably have seen a little bit of that in GCSE, but we take that to the next level. Sequences and series, again, you've done some sequences, but we're looking at now formulas that we can use with arithmetic series and geometric series and things like this. Exponentials and logs is a new topic to you. So a logarithm is kind of the inverse of the exponential, and we'll talk about that and we'll discuss that and understand why that is. And then some of the biggest topics here are differentiation and integration, and vectors is on there as well. Now, differentiation and integration is so big in A-level maths. It's one of the topics that I actually love. It's the pure maths. This is what I actually did at university as well. And it's a really, really good, and it helps you understand a lot of different things. And then all of that links into a big key one, which is the trigonometry side. So that's all the pure side. And then we have a look at the stats and mechanics side. So stats is kind of your data and things like this. So we're looking at things like sampling. We're looking at represented data, so like histograms, cumulative frequency graphs, all things like that. But the key things that we look at are potentially the probability, so the probability of things happening. This could be a Venn diagram, it could be a probability tree, things like this. But statistical distributions and hypothesis testing is quite a big part of this now. Now, you use hypothesis testing to check whether you know a condition to be true or not, and this is something that is used all the time across any kind of data management. So that's why they've introduced it into the A-level. You then look at things like mechanics. So this is kinematics. So all your different Suvat equations, forces in Newton's law. There's a lot of links in the mechanics side to physics. So if you are taking physics, this will really help you because to be honest, they're very similar and they're quite in their structure. And what you learn in physics is exactly the same as what you learn in in mechanics. So these kind of go hand in hand, and it's definitely worth considering taking physics if you are taking A-level maths as well. So in year 13, you will sit 3 examinations in the summer. So Pure 1, Pure 2, and Stats and Mechanics. So the course will be a progression from your year 12 work, with your final examinations being worth 100% of the A-level grade. So this end of year 13, is when you get your full A-level grade. You don't do, it used to be the case where you did it in AS and you got 50% and then you do the rest in A-level, but now everything is towards that end grade. So the core course is based around trigonometry and calculus, like I said, along with other topics like vectors, partial factors, fractions, and natural logs and things like this. So the applied topics will be again continue from the year 12 course, focused on topics such as statistical sampling, probability, kinematics, forces, and I've touched upon all of these already. Okay, so what support will you get? So in year 12, the mathematics department will run sessions one night of the week from 3 till 4. Now this will be support to help you. We've created a load of different resources to really push you. We've created a spreadsheet which helps you with your directed learning. So this is going to be in supervised study. So you've got a load of questions to get on with and really help you. So these sessions are optional, but if you are struggling to achieve the grades in A-level maths, then you will be asked to come to these. So this is to make sure that we're actually helping you and supporting you, because as I said, you don't want to be doing that 2-year course and get to that 2-year course and come out with a grade that you're just not happy with, and the grade that you would have that is much lower than what you would have got if you'd have done a different topic. Okay, so how is work marked? Now, this has changed since the new A-level. It used to be the boundaries were a lot higher, but that's because the papers were a little bit easier. So now the papers are a lot trickier. There's a lot more problem solving in there, which means the boundaries have actually dropped a little bit. So if we look at this now, an A grade is 60%, with an A star grade pushing for like 70%. I've based this on the AS grades for now. E grade is about 20%, D grade 30, C grade 40, B grade 50. Now, all of this is conditional. This is these can change, and they go higher and they go lower, but all your mark will be worked. All of your work will be marked based on this grades. But remember, it's about getting these grades across all of the topics, not just 1 or 2 when you do your low stakes test. Now, this is the exciting part for anybody who loves maths. You will need to get a new calculator. So it's this calculator here. It's called the Casio Class Quiz. Now, this is the one that I recommend. This is the one that the A-level recommends. You can actually get a graphical calculator that will really help you with this as well. But this one is really, really good. It's called the Casio FX991EX. You can get it from places like Tesco, you can get it from Amazon. Sometimes there's really good offers on, and they range between about £20 up to £30. But you will need this calculator because it does a range of new things. So you can actually solve quadratics on it. You can solve simultaneous equations on it. You can also do things like you can find the probability of a binomial distribution. You can do mean from a group frequency. There's all sorts of things you can do on here. But you will be required to use it because you use it all the time, especially in things like stats and mechanics, and actually when you're solving equations which are trickier. So I've put this question here. So what I'm going to suggest that you do is pause now and have a little go at this question. So pause now. Now, this is an actual A-level question that has come up before, okay? This isn't from the GCSE, but this is an entry-level A-level question. So just to give you a little bit of a taste of what you can already do in the A-level. So pause now and have a little go at that. Okay, so hopefully you had a little go at that. If you did struggle with this, I will actually put a video under here which might help you with this. But I'll pop the answers on. So mark these in green or whatever pen you've got. So there's your answers. Mark those in green. Okay, so I thought I'd take this opportunity to go through one of the new topics which you will definitely come across if you do A-level maths, which is called differentiation. Now, I'm not going to go into too much detail. I'm just going to teach you a little snippet just to give you a little taster of what it will be like. So, when we are differentiating, we're finding something which is called the gradient function. Now, what does this actually mean? Well, we know that the gradient of a straight line is the steepness of that line, okay? So if we look at this line here, we've got a gradient here. I'll make this big for you so you can see it. So here we've got a straight line, and the gradient of that straight line is 3, okay? Which we know, y equals mx plus c. So m is the gradient, don't we know? So, however, not all lines are actually straight, okay? And actually, the majority of things that we look at will be curves, like a quadratic or a cubic or anything like this. So with this one here, we've got a quadratic graph. But we can still find the gradient at a particular point, but we're not finding the gradient of a straight line, we're finding the gradient of the tangent of that point. And this is what the gradient function is. The gradient function is finding the gradient of a tangent. So remember, if we've got our tangent, let me go back here. So our tangent here is, if I've got a curve like so, a tangent is a point which touches the curve at one specific point. And our tangent here is, what we're doing is we're finding the gradient of that tangent, okay? So it's the gradient of that line there at that specific point, okay? So we know that differentiating finds the gradient function, and we also know that the gradient function is the gradient of the tangent at a particular point. So let's have a look at this graph, and let's have a look at these tangents and have a look at the gradient of those tangents at a particular point. So here we've got a quadratic graph going on here. And we're going to start with the point when x is equal to -3. So in this one here, what is your gradient? Well, I've got this here. So our gradient in this case is actually -6, okay? So at -2, what's my gradient? Well, my gradient in this case is -4, okay? So my x coordinate is -1. What's my gradient in this case? Well, this one's actually -2. 0 is going to be 0. We've got We've got 1, which is 2. We've got 2, which is 4. And we've got 3, which is 6. So can you spot a pattern there? Can you spot a pattern to see what that gradient function is? So we know to find our y value, let me go back over here. We know to find our y value, we use y is equal to x squared. Okay, so we sub in whatever our x value is to get our y value. But what is my function here to give me my gradient? Remember, dy by dx is my gradient. Well, I think a lot of you might be able to spot this, and I think that most of you should be able to see this. And actually, for this case, the gradient function of x squared is actually 2x. Okay, so the gradient function of x squared is 2x. Now, this isn't always the case. It's not always the case where you double it and you get the gradient. But there is a special formula you can use. Now, when we do this in A-level, we'll go on to look at doing differentiation from first principles and actually show you all of the proof behind all of this. But just for today, I'm going to show you a quick way for looking at it. So we've said that gradient is equal to 2x. So whatever our x value is, the gradient is double that. Now there is a quick way, as I said. Now this is the important part for this. So if you've got any curve which is in the format y is equal to ax to the power of n, then the differential of this is that you subtract 1 from the power and you multiply the power by the coefficient in front. So dy by dx is equal to an x to the power of n minus 1. Now you might think to yourself at this stage, what the heck does that mean? Well, don't worry too much about this at this stage. I haven't gone into too much detail, but this is how we find it. So why does that work for this one up here? Well, if we think about it, if I'm differentiating this, I times the front number, the coefficient, by 2. So you times by the power and then subtract 1 from the power. So 1 times by 2 is equal to 2. And then subtract 1 from the power. So 2 take away 1 is 1. So it'd be 2x to the power of 1. But I don't write 2x to the power of 1. I just write 2x. And this is how we differentiate using this formula here. It will start to make more sense when you see some examples. And I've got some examples here for us to have a go at. So let's have a look at this first one here. So our first example here says y is equal to x to the power of 5. Well, if I'm differentiating this, so I'm finding the gradient of the tangent at any point, I times the 5 by the number in front. So 5 times by 1, which is 5. And then I subtract 1 from the power. So 5 take away 1 is equal to 4. So this here is the gradient function for y is equal to x to the 5. Move that over slightly so you can see it. Brilliant. So that's the first one. You might, if you want to pause and have a go at some of these, if you feel as if you know what you're doing with this, then maybe pause and have a little go now and have a go at the rest of these, okay? So maybe pause now and have a little go at those. So I'm going to have a go at the rest of them. So the next one is y is equal to x to the power of a half. Now, when it's these ones here, it is quite straightforward. You times by the power, you subtract 1. So it's going to be dy by dx. So the gradient function, remember, we're finding the gradient of the tangent at a particular point is half times by 1, which is going to be a half, x. Now, a half subtract 1. Well, if you think about it, what's 0.5 take away 1? 0.5 take away 1 is negative 0.5. A half take away 1 is a minus a half. And this is the gradient function for this one here. Super. Let's just check those two examples just to make sure we're on the right track. Again, you might want to pause if it's making a little bit more sense now. So let's have a go at this next one. So y is equal to 2x to the 6. So with this one here, it's a little bit different because instead of having a 1 in front of here, we've got a 2, but it's exactly the same rules. So dy by dx for this one is going to be equal to 6 times by 2, which is 12, and then subtract 1 to the power, so 6 take away 1, which is 5. So this here is our gradient function for that one. Okay, so let's have a look at some trickier ones now. In fact, let's just check that answer first. Brilliant, 12x to the power 5, super. So this next one here is a little bit trickier, and the reason it's a little bit trickier is, notice they write f of x this time, so that's just the function of x, is because you've got x on the top and x on the bottom, x to the power of 4. Now with all of these questions, what you must do is you must write them as a single power of x. So the first thing I do with this is I would use indices, the laws of indices, to change these into one single power of x. So here, it's going to be x to the 1, and when I'm dividing, I'm subtracting the powers, so x to the 1 divided by x to the 4 is equal to x to the minus 3, and that's your starting point. And then if I want to differentiate this, now, I haven't actually showed you this yet. When we're using y, we differentiate, and we usually write dy by dx. When we're differentiating f of x, we usually differentiate and do f to the f dash of x, okay? So this is the way that we represent a differential if we're using functions. So if I've got my function, which I've just simplified, which is f of x is equal to x to the minus 3, and I want to differentiate this, well, the differential of this is going to be f dash of x is equal to negative 3 times by 1, which is going to be negative 3x, subtract 1 from the power, which is going to be negative 4. Super. So we've got one more. Notice that they're going to simplify it. Yeah, perfect. Oops. Get these answers back up. So negative 3 to the negative 4. Now, this one here, y is equal to the square root of x to the 6. Now this one's here is a little bit trickier. Again, we've got to have it as one single power. So the first thing we're going to do with this is we're going to write this as x to the 6 all to the power of. Now the other way to write a square root is to the half. To expand this bracket, we times the power, so that's going to be x to the power of 3. 6 times by a half is x to the 3. So then when I'm differentiating this, it's going to be dy by dx is equal to, bring the power down, 3x to the power of 2. And remember, this is a way of finding out the gradient of a tangent to a curve at that particular point. Now, brilliant. Now here we've got a question. It says here, why would it be incorrect to say that y is equal to 2 to the x differentiates to x 2 to the x minus 1. So I want you to just have a little think about that. I'll make it big so you can see it. Why does that not differentiate there? Okay, so I'm going to go through this. The reason that this doesn't differentiate is because it's not in the format that we want it, and this is a common mistake. So this is just highlighting the common mistake. Remember, we need it to be y is equal to ax to the power of n. And if you look, this one here is y is equal to, it's the other way around, isn't it? It's a to the power of x. So we can't use our normal differentiation techniques because it's the other way around. It's a to the x instead of x to the n or x to the something. So let's just see what they say there. So the rule only works when x is the base, okay? And the power is the constant. So this one here does not have, so y is equal to, it doesn't have x as the base. Now the base is this bottom part. This has 2 as the base and x is the power. So we can't use that technique, okay? So you'll learn more about ways of differentiating this. And this, remember, this is only a taster of this, okay? This is just an introduction. I'll teach you everything here from first principles. We'll also look at things like why differentiation is so important, so what we actually use it for in the real world. So thank you very much for listening. Thank you for taking part. Hopefully you'll join us to learn maths at St. Thomas Aquinas. Remember, the only way to learn maths is to do it. Keep pushing. Keep remember to do the Mind the Gap pack. That's really important. And have a lovely day.